Well, D.A.R.T's the first planetary defense test that humanity's ever done. It stands for Double Asteroid Redirection Test, and its target is Dimorphos, the moon that orbits around asteroid Didymos. So here we have Didymos, the larger asteroid, with its moonlet Dimorphos orbiting around it. D.A.R.T crashed into Dimorphos at 4 miles per second on the 26th of September, with the hopes to try and slow down its orbit. So in case an asteroid or a comet threatens the Earth in the future, we can do something about it. We can knock it off its course and make sure that we don't end up like the dinosaurs. So we have the Sun, and around that, Didymos orbits. And then around that, a moon, Dimorphos, orbits around that asteroid. And what we're trying to do is when D.A.R.T hits it, we want to make its orbit a little bit shorter. We want to change its orbit so that we can see that it's doable. So, in case, say this is the Earth, and in case there's a comet or an asteroid that comes this way, we can, years in advance, just knock it off its course so that it just narrowly misses the Earth, so that we're safe.
Brilliant.
So, when the moon passes in front of the asteroid that we see from Earth, the brightness dips a little bit. And then once it passes again, it rises back to its normal level. Mm-hmm. So that's for the first orbit. But then once we hit it, we hope to change its orbit so that it's orbiting a bit quicker, so that that dip isn't as big as it was. So it's a good idea. It seems safer to do it that way, but realistically, it's not. So if we blow up the asteroid into bits, that's a lot more asteroids that can endanger Earth, so that's just making the problem worse. But if we were to nuke it like films like Deep Impact and Armageddon do, it's unreliable. We don't know where the bits are going to go, we don't know which way it's going to go, so we might be just delaying the problem and killing ourselves in 100, 200 years' time. If we can knock the asteroid years before it's meant to hit the Earth, we can deviate its orbit enough so that it avoids Earth safely and it goes into an orbit that we know is safe. But if we say we're to blow up the asteroid here, massive nuke there, well, we don't know where it's going to go. It could go in any direction, and that's just making the problem worse in the future, and we'll have to do this again. So, in space, we don't have two things that we have on Earth. We don't have gravity, and we don't have air, which causes air resistance. So both those things slow things down. So for example, say this chair's the asteroid, and the carpet is air. Well, the carpet slows down the asteroid, and it stops. But in space, there's nothing to stop it. So it'll just continue going forever until it hits something. So until that chair hits something or is pulled in by something else, like gravity, then it'll just carry on that course forever. So if we can knock it a little bit out of its way, it'll keep on going straight and keep on going around the sun, but on a slightly different path than it would. So we don't know yet. It's going to be a couple of weeks, months, might be a couple of years until we're sure about its new orbit. But from ground-based observations, it seems like it made quite a mess, and a lot more mess than we expected, which is promising. So we're hoping that it did at least knock it somewhat, so then we can, in the future, know how to refine this process. Yeah, so there's no danger of these asteroids to the Earth. So the bigger one, Dimorphos, is still going around the sun. That's not affected at all. That's still going on the same path it's been going for thousands, if not millions of years. So the smaller one's still going around it, but its orbit is slowed down a little bit, so it's a little bit closer to the asteroid. So this hasn't been thrown off. We know that, we've seen that from Earth, that it's still around it, but we don't know how quick it's orbiting and how much the impact affected its orbit. So at the moment, there's nothing threatening the Earth. There's a lot of observations and a lot of telescopes dedicated to trying to find these near-Earth asteroids which are a threat to Earth. But currently, they're fine. There's nothing around. And even if there was, we've still got backup plans just in case. Whatever we discover from DART will be a success, because from that we can build on it and refine the process to make sure that we can knock something off its course in a reliable and safe way.